So here we shall explain the concept of some properties of matrix multiplication with some more examples. So the first property of matrix multiplication is that if A is of the order, means A is equal to Aij M cross N, suppose, and the matrix B, it is of the order Bij, which is of the order P cross Q, suppose, then N should be equal to P if AB is defined. If the product AB is defined, then N should be equal to P. It means that the product AB is defined. Product AB is defined if N, which is the number of columns in A, that should be equal to P, which means it is equal to the number of rows in matrix B, and the product BA is defined. Product BA is defined if the number of rows, it means if the number of columns in B, which is Q, that should be equal to the number of rows in A. It means it should be M. So if I tell if M is equal to Q and N is equal to P, it means B also should be of the order like this. B should be Bij and P cross M. In this order it should be. Means, sorry, it should be N cross M. P is equal to N and Q should be M. So if A is of the order M cross N and B is of the order N cross M, then both the products AB and BA are defined. Then both the products AB and BA are defined. Then the second rule is that multiplication of two matrices are not commutative. Multiplication of two matrices is non-commutative. It means that the product AB is not always equal to BA. Product BA AB is not equal to BA, even if both are defined. In some special cases, it can happen that AB equal to BA. So AB equal to BA can be possible in some special cases, but it is not necessary. It is not necessary. Suppose, for example, A is of the order M cross N, and here suppose B is of the order N cross M. So the product AB is of the order M cross N, and the product BA will be of the order N cross N. So here it is not necessary that M cross M means M is equal to N. So M can be less than M also, N also, or means M. So if M is not equal to N, then AB and BA are not equal. AB and BA are not equal. And they are not of the same order also. It means they are not of same order also. And then the next property is so if the product AB equals to 0 matrix, if AB equal to 0, then um, it is not necessary that either of them should be 0 matrix. Then it is not necessary, that any one of A and A, or any one of A and B is a 0 matrix. So we can understand this by using some examples. And then some more properties are, matrix multiplication follows the associative law. Matrix multiplication follows the associative law. It means that if we do A into B into C, it means we take the product of A and B. With that, we take the product with some other matrix C. Or if we take the product of B and C and then we take its product with A. So that will give us the same result. So AB into C, that is equal to A into BC if both sides of the equality are defined. If both sides of the equality are defined. So here A, B, and C are three matrices. A, B, and C are some three matrices of the appropriate order. It should be of the appropriate order. It means that if A is of the order m cross n and B is of the order, suppose n cross p, and C is of the order p cross q, then only the product AB into C will be defined. Then the product ABC will be defined and will be of the order Now A into B will be of the order m cross P. So m cross P into C, C is of the order P cross Q. So AB into C will be of the order m cross Q. Okay. Then the fifth property is that the matrix multiplication follows the distributive law. It follows the distributive law. It means that the matrix multiplication is distributive over addition. Matrix multiplication is distributive over addition. Distributive over addition. So it means that if we have three matrices A, B, and C, then A into B plus C should be equal to A into B plus A into C. And also A plus B into C, that should be equal to AC plus BC. A into C plus B into C. So here B and C should be of the same order if they can be added. And here A and B should be of the same order if they can be added. So here it means that suppose A and B both are of the order, suppose m cross n, and C should be is of the order n cross p. Then only this A plus B into C will be of the order, will be defined, and will be of the order m cross p. Similarly here if A is of the order m cross n and B and C both should be of the order, suppose n cross p, then only this A into B plus C will be defined and will be of the order M cross B. Then the next property is um, existence of multiplicative identity. Existence of multiplicative identity. So if A is a square matrix, and I is also the identity matrix of the same order as A. So it means that if A is a square matrix, suppose of order n, and I is also the identity matrix of the same order n, then A into I is equal to I into A, that is equals to A. So the identity matrix I is called the multiplicative identity also. It's called the multiplicative identity. And then existence of multiplicative inverse. Existence of existence of multiplicative inverse. So if A is a square matrix and I is the identity matrix of the same order n, and I is also the identity matrix of the order n, and also B is another square matrix of the same order n. B is also another square matrix of the same order n, such that A into B, that is equals to B into A, that is equals to I. Then the matrix B is called the inverse of the matrix A, is called the multiplicative inverse, of the matrix A, and is written as A inverse, So A into A inverse, that is equals to A inverse into A, that is equals to I. So now suppose we can do an example on the matrix multiplication. So if we have the matrix A, which is 2, 2, 3, and the matrix B, that is equals to, suppose, 5, 6, 7, then we need to find the product. Suppose AB has been asked, and the product BA is asked. So now here matrix A is of the order 2 cross 1, and the matrix B is of the order 1 cross 3. First 1 row and 3 columns. So therefore the product AB is of the order 2 cross 3, and the product BA is not defined. Since why? The number of rows in B is 3 and the number of columns in A is 2. So it is 3 and 2. So BA is not defined. So now Therefore, the product AB, how to find that, is equals to 2, 3, then 5, 6, 7. So this will be equal to, so 2, 3, so 2 rows, it will have 2 rows and 3 columns. So it will be 2 into 5, that is 10 here. So then first row and first column here, we should use first row in A and first column in B, then first row in A, then second column in B. So it will be 2 into 2 6 are 12, then 2 7s are 14. Then this will be first row in A and first column in B. So it will be second row in A. So 3 5s are 15, 3 6 are then 18, and 3 7 are 21. So this is the answer. Thank you.